So today we'll be talking about probability and statistics. And probability is pretty much the mathematics behind random events or chance. So through probability we're able to mathematically calculate which event is most likely to happen out of a number of random events. So the simplest example of probability would probably be the flipping of a coin. So when you flip a normal coin, it has two sides, heads or tails, and if it's weighted normally, there's a 50% chance of it landing on either side. So the way we can prove this mathematically is by creating a tree diagram. And tree diagrams are essentially just drawings with branches that, and for every event you have, or for every event, you draw a branch for every possible outcome of that event. So for an event like flipping a coin, we would draw two branches. One, since you have since it has two outcomes, one being heads, other being tails, and on each branch you write the probability of that outcome happening. So in this case, it's 1/2 or 50-50 for heads and 1/2 for tails. And so now that we have those two, if we follow those branches all the way through and we write what we get at the end, we get heads equals 1/2. And tails equals 1/2. So that is a very simple example of probability and using a tree diagram. But what would we do if it was a bit more complicated? For instance, what if we had multiple events? Or what if our numbers weren't as simple as 1/2 and 1/2? What if there were different chances for each event to happen? Well, we'll touch on that in our next example. For this example, we'll be looking at a basketball game at a carnival. So, at this carnival, or at this game, you get to take 3 shots at the basketball hoop. And the hoop is so small that you can only make 30% of the shots that you make. And if you make 30%, that means that you're going to miss 70%, since 30 plus 70 is 100, and all percentages are out of 100%. So now that we know this, we have to solve the probability for each shot. And to do this, we'll use our tree diagram just like we did for our coins. So, let's break this up individually into every shot. So let's take a look at shot number 1. So for shot number 1, we've once again we've got to draw a tree diagram, and since every shot has has 2 outcomes, either making or missing, we'll draw 2 branches. So 1 branch for make and 1 branch for miss. And so on these branches, once again, we write the probability. But this time, instead of writing 1/2 and 1/2, we're going to write 3/10 for make. And we're going to write 7/10 for miss. Because 3/10 is the same as 30%, and 7/10 is the same as 70%. So now that we've got shot 1 down, we have to make shot 2. And this is where things get a bit more tricky. So, just like for shot 1, we're going to draw a set of 2 different branches, since there's 2 different outcomes for every shot. But this time we're going to do it a bit differently, because we're going to draw a set of 2 different branches on the end of each of our previous branches. And the reason we do this is because with our tree diagram, we're essentially trying to create a path for every possible outcome. And since no matter what the outcome is of the first shot, you're going to take another shot, and in that shot you're going to have a chance to make or miss. You still get a branch for each one, because you still have a chance of making or missing, if that makes sense. If that doesn't make sense, you can just say that you make it look like a tree. So 2 branches on the edge of each little branch, because trees look like that. So anyway, 3/10 on the top, once again, because you have a 3/10 chance of making, 7/10 chance of missing, and that is for each one. So now that we've got our second shot down, let's take a look at our third one. So same thing, since once again you've got a chance of making it and a chance of missing it for every shot. We're going to draw a set of 2 branches on the edge of each of our previous branches. And we're going to write 3 out of 10 for making, 7 out of 10 for missing on every single one. So, yep, 3/10 make, 7/10 miss, 3/10 make, 7/10 miss. Alright, so now that we've got everything drawn out into a nice organized tree diagram, it's going to be really easy for us to be able to look at all of our possible outcomes. So, like I said, a tree diagram is kind of like a path, and each path represents a different outcome. So let's follow the top path and see which outcome we get. If we make the first shot, well, first let's go up. So we make the first shot, we get to shot 2, we make the second shot, and then we make the third shot as well. So if we follow that, we go through the first check, the second check, and the third check. So let's write down check, 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 since we made all 3 of those shots. Now next, let's go up and we make this first shot, we make the second shot, but instead of making the third shot, we miss the third shot. So now, instead of writing check, 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 we'll write check, check, X for making the first 2 and missing the third one. And so now let's just do the same thing for all the other ones. And we'll write down all the rest of our outcomes. Check, miss, make, miss, make, miss, 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 make, miss, make, miss, make, and all 3 misses. So now we've got all our outcomes. Let's go ahead and calculate the probability that we'll get each of these outcomes. So I've moved our table over to a nice blank slide, and now we can do some math. So let's remember that every check is representative of 3/10, and every miss, or X, is representative of 7/10, since there is a 3 out of 10 chance that you'll make the shot and a 7 out of 10 chance that you'll miss it. So, if we're going to calculate for the first one, the way we do it is we multiply the fractions of each of the we multiply the fractions of the probabilities for whatever you did for the shot. So since the first one is 3 makes, we're going to multiply 3/10 by 3/10 by 3/10. And that's going to give us 27/1000, or 2.7%, because I like writing it as a percent. You don't really need to, but it just helps me organize it better. So that's our probability for making all 3 shots. So now let's move on to making 2 shots and missing 1. So it's going to be the same thing. Multiply 3/10 times 3/10, but this time we're going to do 7/10 instead of 3/10 for the final one, because we missed it instead of making it. When we multiply that out, that gets 63 out of 1000, which is equal to 6.3%. So you might be tempted to just stop there and say, okay, that's a probability for 2 shots, but nope, we've got to do a bit more work, and here's why. If you look closely, 6.3% is a probability that will make our first shot, make our second shot, and miss our third shot. But we're not looking for that specific order. We're just looking to see that if you make 2 shots, miss 1 shot. So let's look everywhere else in our list and see if there's any other places where we make 2, miss 1. We've got 1 here. We've also got 1 here and another one right here. So all in all, there's 3 spots where we make 2, miss 1. So with that in mind, we take the answer we got before, 63/1000, and we multiply it by the number of times it repeats, which in this case is 3. And once we get that answer, we should get 189/1000, which should give us 18.9%. So let's go ahead and box this, since this is our final answer for that. And we'll also box our first answer for all 3 checks, which is 2.7%. And the reason why that one is correct is because out of all the outcomes, there's only one where you would get all 3 makes. So we don't have to do anything special on that one. So now let's move on to 2 misses, 1 make. So if we calculate this out, similar thing. Once again, it's going to be, we're going to multiply by 3/10 for the first one. But then we're going to multiply by 7/10 for the next 2, since you make the first one and miss the 2 following ones. And the final answer we're going to get for this one is 147/1000, which is equal to 14.7%. But remember, we're not done yet. We've got to take a look at all of the outcomes in which there's 2 misses and 1 make and take those all into account. So we've got 1 here, 1 there, and 1 there. So 3 in all. So once again, we're going to do 147/1000 times 3. And that's going to give us 441 over 1,000, or 44.1% that we're going to miss to make 1. So now let's go ahead and move on to our final calculation, which is going to be missing all 3. So this once again, similar thing. We've got 3 x's, which are 7/10 each. So that means that we're going to multiply 7 over 10 times 7 over 10 times 7 over 10. And when you multiply those all together, you should get 343 over 1,000, or 34.3%. So now we have all the calculations for each of our for each of the things we're trying to find. If we make 1 shot, make 2, make 3, or make none. And so now that we know this, let's move on to the next part of the question, in which we're asking, what prize are you most likely to win? So if we take a look at what the prizes are in our question again, we'll see that if you make all 3 shots, you get the wonderful prize of a gigantic teddy bear. And if you make 2 but miss 1, you get, instead of 1 gigantic stuffed animal, you get 1 smaller stuffed animal. If you make 1 but miss all the other ones, you get a plastic puzzle. And if you miss all 3, you get nothing. So let's look at our calculations that I have over to the left and see which one we're most likely to get. So based on our calculations, you are most likely to get, based on our calculations, you are most likely to get the puzzle, because if you look, we have a 2.7% chance of making all 3, which is the least. We have 18.9% chance of getting a small stuffed animal, which is 2 checks and 1 X, or 2 makes and 1 miss. And we have a 44.1% chance of missing 2 but making 1, and a 34.3% chance of missing all 3. So based on this, we can say that the puzzle is the thing you're most likely going to win. So now that we know what prize we are most likely to win, let's take a look at how much money we will most likely gain or lose on average by playing this game. And we can mainly look at this by looking at how much each of the prizes cost. So the first prize, the large stuffed animal, is worth $2.50. The small stuffed animals are worth 60 cents, and the plastic puzzle is worth 5 cents. The game itself is worth 50. You have to pay 50 cents to play the game itself. So now that we know this, let's calculate how much money you would win or lose depending on which prize you won. So if you made 3 shots and you won the giant teddy bear or the giant stuffed animal, you would have negative 50 cents because you spent 50 cents on the game, but you would gain $2.50. So your total would be $2 gained. If you made 2 shots and won the small stuffed animal, you would take, once again, you start off with negative 50 cents because you spent 50 cents on the game, and you would add 60 cents to give you a profit of 10 cents. Now, if you made 1 shot and won the plastic puzzle, you will once again start out with negative 50 cents, and you'd add on 5 cents to give you a loss of 45 cents. And if you won nothing, you would simply lose 50 cents, you would add nothing to that, and you would get negative 50 cents for your total loss. So now that we know how much you will lose based on how much you will lose depending on what prize you will get, we have to calculate the expected value by multiplying these by the percentages of how often you will get this. So let's do this now. So for 3 shots, we just decided that the amount of money that you would gain is $2, but remember, you only have a 2.7% chance of winning this. So let's multiply 2 by 0.027, which is the same as 2.7%. And the answer we should get is 0.005, or is 0.05, sorry. And let's do the same for all the other possibilities. So if we make 2 shots, we said that we would gain 10 cents. So let's multiply 10 cents by 0.189, which is the same as 18.9%. And the answer we should get is 0.0189. And for making one shot, since we said that we would lose 45 cents, let's take negative 0.45 and multiply that by 0.441, since we have 44.1% chance of getting this prize, and our final answer would be negative 0.198. And finally, let's take how much we will lose from making 0 shots, which we decided was negative 50 cents. And we'll multiply that by 0.343, which is the same as 34.3%. And that'll give us a total of negative 0.1715. So all of these values that we got at the end represents the amount of money in cents that you would pretty much lose on average if you played this game 100 times. So in order to find that out, we take all the answers we got at the end, 0.054, 0.0189, negative 0.198, and negative 0.1715, and we add them all together. So once you add these all together, the answer that you should get is negative 0.296, which is about equal to negative 30 cents, meaning that you will lose approximately 30 cents by playing this game per game every time you play. So that concludes today's lesson. Just a wrap up of what we've learned how to take a probability and statistics question, calculate all the possible outcomes using a tree diagram, and then once we have all those outcomes, we were able to multiply different probabilities together in order to find out which one was the most likely, and also be able to find the expected value for how much money you would win or lose for this game. So thank you for watching.